Good morning, students. Good morning, participants. Where God guides, He provides. A very good morning to all the participants. AI is a tool. The choice about how it gets deployed is ours. Orient adjoining. We will be starting our faculty development and empowerment program of day 4, session 1 with our keynote speaker, Mr. Sudhanshu Saurabh. We'll be speaking on the topic neuroimaging and deep learning. Sudhanshu is engineering and technology, Bangalore with over 19 years of experience. Professor Sudhanshu Saurabh holds a MTech in Computer Science from Institute of Electronics and Telecommunication Engineers, New Delhi, and MSc degree in Electronics from University of Lucknow. He has worked at Venture Technologies as software engineer, project consultant at Tiranga Aerospace and institutions such as RKG Institute of Technology, Indraprastha Engineering College, RD Engineering College, Ghaziabad, and Greater Noida Institute of Technology, Greater Noida, in various capacities from a lecturer, senior lecturer, and assistant professor. He has served as a resource person and invited speaker for various workshops, conferences, and faculty development program in various universities in Noida, Dehradun, and Surat. He is a member of various expert advisory committees constituted by Commission for Scientific and Technical Terminology, Ministry of Education, Government of India. He served as an expert member for Glossary of Information Technology, Glossary of Nanotechnology, and Glossary of Insurance with CSTT, Ministry of Education. He has published 5 papers in peer-reviewed and referred journals, which are listed in SCI Index journals, Scopus Index journals, and conferences. He is an active member of various professional, scientific, and technical associations, ACM, IETE, ISCA. I welcome you, sir. May I request Professor Shruti to felicitate our keynote speaker. Thank you, sir. Thank you, madam. Over to the speaker now.
Good morning to all. Yesterday I discussed classification and detection with respect to the general images. Classify the image with respect to the specific category. Yesterday I discussed using some deep learning models and also with respect to the spatial information. I mean, location-wise information of the image. So location is required for the identification. That is very important criteria for each and every kind of the image processing and classification techniques. But in case of a specific kind of the images, like neuroimaging or the medical images, because whatever you are doing in your project or the research or in seminars, any kind of a thing related to the technology with respect to the societal information and societal developments. So it's very much important. Always keep in your mind, technology should be useful for the mankind. If technology is not useful for the mankind, then it's dangerous. So that's why technical growth in our society, keep in your mind, always provide a facility to the mankind. Otherwise, it's not a better to learn the technology with respect to the mankind. Today's my topic is neuroimaging. See, why neuroimaging? The images of the brain, a specific kind of the machines are required to scan the brain and it extract the image. What happened inside our brain? See, most complex part of human body is a brain. Study the human brain, it's a difficult topic. See, many types of imaging tools are there in the market, like MRI, magnetic resonance imaging, functional magnetic resonance imaging, another thing that is called fMRI. Lots of difference between MRI and fMRI. Still, India importing MRI machine from the Netherlands and the US. Still, India is not able to develop their own MRI machine. They imported from GE, Philips, and Schneider's Electric from Germany. Last year, Bharat Electronics Limited, I met CMD of Bharat Electronics Limited. He asked me, "There's some MRI machine." I said, it's possible, but problem is this, it's requiring lots of fund. Second, the technical resources, top class brains are required to develop that MRI machine. Because see, MRI machine works with respect to the magnetic field of the arm. See, the magnetization occurs from north to south and south to north pole. Keep the human body inside the machine and align the human body with respect to the earth directions, north to south and south to north. In this way, that magnetic field resonate around the human body, and specifically it focuses on the brain and then capture the image with respect to the magnetic field which occurs inside the human brain. By this way, that machine capture the image of human brain, that is called magnetic resonance imaging. Second thing, the functional aspect of the magnetic resonance. Functional means the blood flow inside the human brain. By this way, the signals are activated in the brain, and then the human takes an action or emitted voices, gives some uh, representations through their actuators. Actuators means like action taken by our parts of our body, like see gesture. While we are saying something, first the activity occurs. That activity by the blood flow occurs through the density of the oxygen available in our brain. So that's why that a specific signals occurs in our brain. That signal name is called gold signal, blood oxygenation level of dependence, gold signal. By this way, the signals carry the information, and then our actuators of the body, like hand, like our mouth, by this way, they speak the information. Those brains having a little amount less than the normal, less than the threshold value of the oxygen level in the brain, that is called dementia. That is where you can forget the information. People are able to recognize the things properly. These are the many things. These things are called functional characteristics of our brain. So that this functional MRI is required. Another technique for the imaging, positron emission tomography, PET. It means that we put some magnetic devices around our brain, and those magnetic devices taking care of the image. And by this way, we can capture the image of our brain. But that is not to that much level, like MRI and fMRI. So fMRI is still costly, but MRI is not that much costly. But fMRI provides more information than the MRI, so that all these kinds of the images captured by all the devices is called the neuro images. So apply these neuro images. It is visual. This slide is visual to our back side. So fMRI provides more information than the MRI. So better to use fMRI, but it's a costly. And very few hospitals, few organizations, they are using the fMRI for the research purpose and for the mankind. So, see, first, you of this tubelite. So, before starting the neuroimaging with deep learning models, because the machines, these deep learning, yesterday I discussed the deep learning are designed with respect to our brain. I think now it's clearly visible to all. See, yesterday I discussed the CNN models, different types of the model for the simple identifications and all. So today, more specific, that is CNN, convolutional neural network, and the feature attribution, feature extraction and feature attribution, two different things. So feature attribution methods I will discuss today, and the different methodologies That is my methodology actually I developed. And the saliency map. The saliency map is a specific kind of the image in the hidden layers. See, the neural network model are there, input layer and output layer. In between the computations nodes are there, those nodes are called the hidden layers. The collection of all those nodes is called the hidden layers. In the hidden layers, lots of computations. So those hidden layers provides a specific kind of the image while you are training the image data. So that image is called saliency image or saliency map. Another thing, interpretation is most important thing of the deep learning models. If you are not able to interpret the data, then it's a difficult to understand. And then, what kind of experimental data is required? So, brain images is required because neuroimaging is a topic. So that I train the neuroimages and checking the Alzheimer's disease in the brain, where which part of the brain is different than the other part of the brain. See, some specific location in the brain, problems occurs in a specific part, specific location at the brain, so that that part provides the specific kind of the disease, maybe tumor, maybe Alzheimer, maybe multiple sclerosis. Nowadays, multiple sclerosis day by day increasing. So, MSDG is also, so many types of the disease inside the brain. So, that's why it is called the interpretation of the models. And final thing is attributions. And I am using the data set for the training purpose along with the neuroimages. That data set is available on the internet. It's called ImageNet. So it's for the deep learning models. So that's why you can easily download it from the internet. And then the gradient information, that is important point. Gradient value of the ImageNet data set. See, two aspects, gradient and the perturbation theory. See, all of you have some mathematics background or not? Raise your hand. Huh? Okay, good. So, today, the CNN, how CNN learn the raw images in the form of the pixels. Pixels means numeric value. So we train the image in the form of a pixel, not kind of image information, connected values, graphical values. We'll train the data in the form of a numeric values, not in the form of a pattern, not in the form of a connected data, not a continuous data. These are called discrete data. There are lots of difference between discrete and continuous. Once it is a discrete, then we can connect one by one node with each other, then it becomes a connected data and creates a specific kind of the pattern, and then finally it will display the result. It's a responsibility of the hidden layers. That's why the features are connected by the hidden layers and creates a specific kind of the result in the hidden layers, so that that image is called the saliency map image. Second thing, those edges means if there is a two or more than two pixel informations, we want to connect those two pixel informations together. By this we will generate the edge. That edge is called pattern, a specific kind of the pattern, so that it generates an image. Next quality. The third quality is the third property, or you can say the quality also, texture. Write the information. Write the information means in the form of a text and generate a color value, which color will differentiate from rest part of the locations. That specific location is differentiated by the color from rest part of the location or the images. So, what are the techniques? There are two techniques. The first technique is grade cam technique, and that technique is calculated by the perturbation theory. perturbation theory is totally based on the probability along with the integrations. To integrate all the probabilities together to generate the gradient image. Second concept is salient object detection. The object which is not visible, the object which is not visible, then again you have to use those probability to generate the heat map. Heat map means the hidden images generated by the hidden layers. That's why it is called heat map. And the color quality is totally different than the rest part of the images. So look at here. See how to generate the saliency map. So regularization. This is called hyperparameter of the deep learning model. That is convolutional neural network. So regularize the data. It means that some learning rate is equal to put 0.1 to 0.00010 to the power minus 5. This is the limit. It started from 0.1 to 10 to the power minus 5. So this limit you can keep and learn, provide some learning rate inside the hidden layers. And hidden layers takes a responsibility to calculate the input data with respect to some activation function also. One hyperparameter is a activation function, another hyperparameter is called regularizations. Next, another kind of the hyperparameter is also required, that is called hyperbolic functions. Hyperbolic functions means sin theta divided by the cos theta, that is called tan theta. And that tan theta change another kind of the function that is called hyperbolic function, then that is called tan h theta. So each and every layer consisting a learning rate, hyperbolic functions, and Adam parameters, all those parameters to apply in the hidden layers, and it generates the image. So this is the first step. Second step, for the pixels, those pixels are in the form of a numeric data. So first, what you will do, minimize the pixel. For the minimization purpose, it will be location value. It holds the location value because x-axis and y-axis, two-dimensional plane. So that if you want to fetch the particular part of the image, then you can use the x point and the y point. If 2 points are there, then by this way you can fetch the pixel information and minimize those pixel information. See how minimization occurs at the plane. Then differentiation is a tool which is already available in the mathematics. Apply differentiation. By this way you can minimize any data in the location because this is a localized data, so that you can minimize the pixel. That's why partial differentiation, because the two-dimensional axis, then first you differentiate x, then second you differentiate y. So that's why partial differentiation is required for the x and y. And probability of each values with respect to x and with respect to y is denoted by the probability of x locations, x-axis locations and y-axis locations, then p of x and p of y, then of p of x with respect to y, or any with respect to time, with respect to location, whatever. And similarly, you can provide information with respect to the y-axis. By this way, you can minimize the pixel values. So this formulation, this is a very simple formulations, that is a binomial formula. Look at here, p to the power x, 1 minus p to the power 1 minus x, right? This is a binomial data set, because binomial is a very good kind of a distribution formula. And like Gaussian distribution is also normal distribution, Poisson distribution. So many types of distributions are there. But see, you should know which distributions is most important with respect to your project, your data set. Okay. So binomial is better than the Gaussian, because Gaussian is a normal kind of a distribution, the curve generates like that. So it's not useful. Poisson generates exponential growth kind of a curve. So that Poisson is not useful. But binomial is okay. Something. Linear kind of a curve. So it's a better. So what is this? The feature values, feature is pixel values. Those feature values are n number of features are available in the numeric form. So that these features value are trained with respect to the region information which is generated by the hidden layers and some activation functions. In this particular data set, I am using the softmax function for specifically the dense layer. Yesterday I talked, I discussed also what is the fully connected layer or the dense layer. So that apply the softmax functions and the framework you have to provide it. That framework is called probability again. But I know this is a little bit complex because apply the mathematics in the neuroimages and then check the signals. I know. But see, this is simply introduction to all. This is merging field of the neuroimages with the mathematics. Being an engineer, being a computer scientist, to try to understand. That's why I told you, whatever the project, whatever the research you are doing, this should always, with respect to the mankind. If it is not related to the mankind, then it's useless. To keep always in your mind, whatever you are doing, that always with respect to the mankind. See, in 2020 and 2021, we all saw, and that COVID. So COVID affected to all. Lots of researches are going on, and they developed a medicine. So for similarly, whatever the domain you like, you can apply your technology in that particular domain and develop something. That's right. So all those pixels values generated the region-based saliency map. Why region is required? Because locations in the brain, different locations, left, right, front, back, then that's why the cut axis of the brain, x-axis, y-axis, z-axis, when you are considering the three-dimensional image of the brain, four-dimensional image of the brain, n-dimensional image of the brain. So that each and every location, different points are there. So connect one by one, each one by one locations. So that the real valued function is denoted by r to the power c of I. That real value means the numeric data always belonging to the real numbers. That's why that is called the real value function to the power ci, which is math between 0 to 1. That c is called the person who is affected from the Alzheimer disease or any kind of the disease, and person who is not affected from any kind of the disease. There are two types of the brain image. So how to classify the healthy images and the disease affected images of the neuron? So that is belonging to the 0 and 1. If 0, then the person is called healthy. If more than 0, then the person is affected by the disease. So that disease is Alzheimer, that disease is tumor, that disease is different kinds of the names. So the attribution vectors denoted by the V. This attribution is called map, image generated by the hidden layers. That's why it is a attributions. Those attributions, what you will do? You will do with some constant value that is called alpha, original image minus the computed image. Yesterday I discussed it. The required data minus calculated data. Required data minus calculated data, that is not matched. Then some numerical value is generated, and that is called error. That's why the same formulations, don't forget, the same formulations you can apply over here, and original data is denoted by the N and the I. with some constant value alpha and integrate all those values together and it generates the image. See, this is the model what I developed. See, these two images, one is image of the human brain, another is a Alzheimer affected brain. Two images. And there is a difference between both the images. See, a human brain, two images. The second one is healthy. And sorry, first one is a healthy and second is a this is a healthy image and this is a Alzheimer affected brain. So there is a difference. See here, the difference properly it's visible. But which part is affected more? To apply your technology. This is generated by the MRI machine. These two images are generated by the MRI machines. And here is the result. See, here is the result generated by the deep learning models. You apply the deep learning model, train the image, generate the data. See how properly colorization of each and every part of the brain is generated. So easily you can identify which part is affected more. This particular part is affected more because the pixel value of that particular color is more. The intensity of that color is more and that location. So before starting the training of this video imaging, first you learn what is the neuroimaging. I discuss second part of this lecture. See, and this, see, look at here. This is a model, deep learning model. This is called deep learning models. And these images here and here, it's called a saliency image. And these saliency images are here and here. These saliency generated by each and every layer with your some kind of mathematics, and those mathematics are taking care from each and every layer and generate the pixel values. Those pixel values are very important. See, the data set I am using from the Harvard data set. So you can use also. This data set is freely available. That link I am provided here. You can use this link. med.harvard.edu. From there you can download the video data set. Video data set is available because MRI data is always video data. You can convert it to a frame data. See, this is actually the weight value. How much activation you are providing to the hidden layers. Hidden layers means these are the hidden layers. First one, bigger, this big layer is called the input layer. But in between all this, before this black, all these layers are called hidden layers, and all kind of the integrations, exponential value distribution, probability theory you can apply over the hidden layers. All kind of the hyperparameter also you can apply here, and by this way you can generate the result. That's why this is called hidden layers. See, so the red color graph and the blue color graph, these two lines showing the minimum weight in the hidden layers means the minimum activation parameter, minimum learning parameter, and the Adam parameter. Those three are called the hyperparameters. Minimum and maximum both are generated by your models after training. See, and see this specific images generated. See the affected region of the brain. So this is a healthy image. MRI machine is here. Your deep learning model, convolutional models generated. See this specific image, and this is belonging to the healthy. Okay, and these are the points which is called activation points, working state of the brain. These points are in the active state. See, this is Alzheimer affected brain and active state, and specifically pointed some special point. That point is called the affected region of the brain, and you can check over here the maximization of the pixel value by this way to calculate the pixel value. By this way, you can declare that this brain is affected by the particular disease. That disease is called Alzheimer disease. By this way, you will forget the information. They are not able to imitate. See the result maximum. By this, you can generate the result also for the gradient information of the pixel values. For the healthy images, the pixel values and their result are like this. But here you can say the gradient value are deferred. See the numeric data deferred here. So it is maximized and it is minimized with respect to the healthy images and see the result. Well, this red line, see the red line value and red line value, it is maximized, it is minimized. So that by this way you can easily predict this brain is affected by the particular disease. And also the maximization, black is this line you can see. The point is pointed over here and this point is pointed over here. That it is maximized so that this part is called the Alzheimer affected brain. See the numerical data. How to calculate the numerical data? The numerical data with respect to the graph, you can calculate point by point the numerical values. Look at here, most affected these ones binary value ones, and here the binary values ones. The x minus xi original minus computed. See these are zero. That much okay. But after this number of ones is more than the number of ones in the healthy images. So that by this way you can declare this part is affected and this part is not affected. Understand? Huh? Basic idea. This is basic idea. I'm not taking about much. See. Now look at here. Activity. How activity occurs in the brain. That much okay. See, activation occurs through the bold signals. Those bold signals is responsible for everything, whatever the things occurring in our brain, because of the blood oxygen level in our brain. So that activity is started in our brain. Simply, when you open your eyelid, and then yesterday I again discussed it. See, eyelid is very informative. Opening up the eyelid, receiving the information, and then immediately blood is flowing in the capillaries of the brain, and by this way activation occurs. So those activation is called signals. See, and those activations needs conscience, cognizance in our brain, and that cognizance is totally based on our psycholinguistics manner. Psycholinguistics means psychological aspect of our brain and the linguistics aspect of our brain. Whatever the language you know and whatever the psychology which you are carrying in your brain, that is called synapses area of the brain. So synapses means memory. So both are combined together and generates cognizance. So our conscience, you can say, the cognizance are generated again by the bold signals. So that's why these activities are very much important. What kind of the data required for the training purpose? Those data are called dimensional data of the brain, first thing. Sources, variability of the data, and liability of the artifact. Liability means left movement of the brain and right movement of the brain, because brain is divided into two parts, left and right. The left movement of the brain and right movement, then left activity and the right activity with respect to the X cut, Y cut, and Z cut of the neuro image. So these three kind of a data set are required before training the data. See, the basics which is required before starting the project of the neuroimaging. quality control. First thing, data should be properly pre-processed. If it is not properly pre-processed, then it will not generate a proper result. It generates a uh, different kind of the result. I mean, the desired result and the calculated result are huge difference. So that it will not proper. So quality of the data is necessary. How to provide the best quality of the data, pre-process the data properly. Means proper mathematics is required to pre-processing. Second, distortion, any kind of the noise which occurs in the image, that noise you have to remove in the brain. That's simply you can say that white noise which occurs in the brain while you are uh, collecting a neuro image, I mean fMRI image or MRI image. So remove the white noise. Motion corrections. The brain should be a fixed state. It should not move. Okay. Brain should be a fixed. Put it in a constant mode, fixed mode. By this way you can generate the proper image. Second, slicing. X slice, Y slice, Z slice. Cut. Cut of the brain image. Cutting. X cut, Y cut, and Z cut. Three-dimensional data is very important rather than the two-dimensional data. But while you are cutting the data, then you convert the three-dimensional data into the two-dimensional data. So slicing is very much important. Spatial normalization. Probability is required over here for the normalization purpose. Locations normalization. So better to use the Gaussian or the binomial distribution for the normalization purpose. And smooth. Smooth means all the pixels should be a proper manner. Means once you normalize, then smooth the pixel values of the image. And then temporal. Temporal means time series. Each and every pixel with respect to the time. Because while you are going to minimize the pixels, then the time is required, del x by del t. That's why each and every time you collect the information of the pixels. And then statistical data, randomization of the pixels. So that statistical value is also required. And then finally visualization of the pixels. So that what what kind of the colors available in the brain that is generated by the hidden layers. That color is very much important. So that visualization is the last aspect of all these parameters. See, the software is those software packages are SPM, FSL, AFNI, Brain Model. You can use these, you can download these tools. It is easily available. Easily available. You can download all these tools and train the brain image. Get the result. But environment is also necessary. If you in your system MATLAB is there, then SPM is working. If MATLAB is not there, then it will not work. And FSL, AFNI, it work only with the Linux or Unix based system, not a Windows based system. The first one work with a Windows based system, SPM, but SPM is not working with the Linux and the Unix based system. And brain boiler is also necessary. This is good actually because it is working with the Windows, Linux, and Mac systems. So it's a good, most widely used software is a brain boiler and SPM. See, all those steps, how to solve all those steps. This is a framework. In this framework, the image reconstructions is required, distortion correction, I mean the noise removal is required, the motion corrections, fix the brain images in a constant values, and the slicing is X, Y, and Z, those slicing with respect to the motion correction. So both are correlated with each other. Once they are correlated, then apply the Pearson correlation formula and get the covariance. And see, The spatial normalization and statistical analysis is also required because human brain is so complex. To keep in your mind, many kind of mathematics is required. So, for the spatial information differentiation is there, for the randomization, statistics is there. So both are combined together and it will generate the propaganda. So, see, look at the three cuts are there. That coronal, axial, and sagittal. Three cut of the brain. Coronal with respect to the x-axis, axial is in respect to the y-axis, and sagittal is in respect to the z-axis. So three types of the cut of the brain, and the specific names are coronal, axials, and sagittals. And their numeric value for each location is denoted in the matrix. This point is denoted in the form of the numeric value. See, while you are training, rotate the image, rotation about x-axis, rotation about, because three cuts are there, then three types of rotation is required for the motion corrections. Those rotations is called x-axis, y-axis, z-axis rotation. Also provide the rotation of the image. And then finally it generates the image. That image is called T1 generated, T2 generated image. So T1 and T2 is magnetization. So that finally it generated the gray color image and colored image both, RGB and CMY both. So here I am using the gray color image, then it simply generated because the color image takes us so much time to train. Because nowadays the machine is not up to that level to the it generates a result. It takes 4 to 5 hours to train the data. Simple laptop. My laptop is GPU based, but it takes 4 to 5 hours to train this much data. So it generated a result. And see the final value. Final value of the affected region. It is denoted here by the maximization of the black dot. Look at here. And that is called affected by the simple calculation before the training, before the pre-processing. This image is generated by the simple mathematical calculation. And that's it. See, 1 minute. See, this neuroimaging, once you understand this concept properly, the two things, two different aspects, medical and technology, both are combined together. The neuroimaging techniques and the technology, along with the mathematics, then you can generate a specific result of the MRI images and MRI images. Both kind of the images are used here. I trained the deep learning model with fMRI, but in the second part of this presentation, I am using the MRI image. See the difference between MRI and fMRI. This is not that much level. Data is okay, everything is okay. Visualization is not that much good while you are comparing with the deep learning models. See, look at here. This is a big difference. So that's why the neural network model is much better than the simple kind of an algorithm. So it's good to use a neural network based model for the classification purpose, for the clustering purpose, for the identification purpose. Many works you can use the deep learning models instead of the simple algorithms. So it's better to use. So this is my suggestion also to all of you. Those who are interested in the neuroimaging field, then first thing they should learn the basic mathematics and basic computer graphics. By this way, you can solve the classification of the neuroimaging data. And finally, also one more suggestion, sir. Probability and statistics is also required. So you prepare all those three concepts, then you go for the neuroimaging along with the deep learning models.